In this video, we're going to look at more applications of linear systems, specifically mixture problems and speed distance time problems. So here's a very common example you might see. You need a 15% acid solution for a certain test, but your supplier only ships a 10% solution and a 30% solution. Rather than pay the hefty surcharge to have the supplier make the 15% solution, you decide to mix 10% and 30% to make your own 15% solution. And you need 10 liters of the 15% acid solution. How many liters of each should you use? So this is a very common mixture problem. And let's just look at that final question. How many liters of 10 and 30% should you use? Those are your let statements. I need to know the liters of 10% and the liters of 30%. So there we go. Let X represent liters of 10%. Let Y represent liters of 30%. And now let's go back and read some statements to get our two equations. Here's the first one. I need 10 liters. So I'm going to mix X liters of 10%, Y liters of 30%, and together I should get 10 liters in total. So your first equation will be a very basic one where we add X and Y to get our total volume in this case. X plus Y is 10. Now the second equation is based on this 15% acid that we need. If I take 10% of X, I will get the pure acid that comes from X. And if I take 30% of Y, I will get the pure acid that comes from Y. And if I add the amount of pure acid coming from the 10% and the 30%, I should get the amount of pure acid in my final solution. And my final solution is 10 liters and 15% acid. So 15% of 10 will be pure. So here's the mixture part. I want 10% of X. So usually you turn 10% into its decimal and multiply it by X, but we can just use 10 as long as we're consistent with our other percents. So I'm going to take 10% of X and 30% of Y. So this is the pure acid coming from my two solutions. And if I add them up, I should get the pure acid in my mixture, which is not just 15. It is 15% of 10. Notice here, you're taking a percent of a volume. So when you set it equal to something, it can't just be equal to 10. It has to be equal to a percent of a volume. So then I can clean up the 15 times 10, and then I can do substitution or elimination. And I'm just going to do elimination. So I'll rewrite this one as 10x plus 30y equals 150. And I'm going to multiply this first equation by 10 so that I can eliminate the x's. So 10x plus 10y equals 100. And now to eliminate my x's, I'm going to subtract because 10 minus 10 is 0. 10 minus 30 is negative 20y's, and 100 minus 150 is negative 50. And then I can divide both sides by negative 20, and I get 2.5 liters, and that's for the 30% if I look at my let statements. And if I want to figure out the number of liters of 10%, I'm just going to sub it into my first equation. So I'm going to sub it in here, and I'm going to write x plus 2.5 equals 10. So I can bring that 2.5 over and subtract it from 10. And I get 7.5 liters of the 10%. And there we go. That's it. So now let's write our therefore statement. Therefore, you should mix 7.5 liters of 10% and 2.5 liters of 30% solution. And there it is. And now it doesn't just have to be about acidic solutions or anything chemistry related. It can be about a granola mix or you're using like Kool-Aid mix or sugar concentrations, anything concentration related really. So let's look at our next one, and we're just gonna set this one up. So one type of granola contains 30% nuts and another type is 15% nuts. What mass of each type of granola should be mixed to make 600 grams of granola that is 21% nuts? We're just gonna set this up. So we wanna know how much should we mix, or what mass of each type of granola should we mix to get this mixture that they want. So those are our let statements. Let X represent grams of 30%. Let Y represent grams of 15%. And I know in total I need 600 grams. So if I add up the number of grams of the first mixture and the second one, I should get 600 grams in total. So that's the simple equation. Now we need the mixture one. If I take 30% of the first granola, so 30x, and I add that to 15% of y, so 15y, I should get 21% of 600. Because this is going to tell me the grams of nuts from one plus the grams of nuts from the other one. And in total, I'm not going to have 21%. I'm going to have the number of, or the grams of nuts from my mixture, which is 21% of 600. So we have to stay consistent. And then from here, you can go ahead and solve. Now, mixture ones are also sometimes in terms of money, not just percentages. So let's try this one out. Pineapple costs $3 per pound and strawberries cost $1.50 per pound. If you want to make a 12-pound platter worth $24, how many pounds of each fruit should you add? So there's our let statements. How many pounds of fruit should you add? So let X represent pounds, or the LB is the notation for pounds, of pineapple. Let Y represent the number of pounds of strawberries. And our first equation will come from the total mass, which is 12 pounds. So if I add the pounds of pineapple and the pounds of strawberries, I will get 12. So there's the basic one. The next one is the money worth. So each pound of pineapple costs $3. So if I had 2 pounds, I would do 3 times 2. If I had 5 pounds, 3 times 5. But I have X pounds. So 3 times X will be the money or the cost of pineapple. And for strawberries, it's $1.50 per pound. So 150Y. And when you add the cost of pineapple and the cost of strawberries in total, it should be $24. And notice, I'm not going to do 24 times 12 because it's not $24 per pound. It's just a total of 24. So I don't have to worry about multiplying 24 by anything. So really be careful with the wording here. And now we can solve this. And in these scenarios, I personally like to do elimination. I find it a little easier, but you can definitely isolate for X or Y and then sub it in. And I will do substitution here because I haven't done it in this video, just as a refresher. So I'm going to take this first equation and I'm going to isolate. I'm just going to isolate for X, which means I'm going to bring the Y over and it becomes negative. And now that I know what X is equal to, I will replace X with that expression in the second equation. So 3 times 12 minus Y plus 1.5 Y equals 24. And now we can distribute the 3 in. 36 minus 3Y plus 1.50Y equals 24. And now let's just finish this off. So let's bring the 36 over. And it will become negative. And then negative 3 plus 1.5 is negative 1.5Y. And 24 minus 36 is negative 12. And then we can divide both sides by negative 1.5. And we get Y is equal to 8. Now we can take that and plug it into one of our original equations. So X plus 8 equals 12. Bring the 8 over. So we get 12 minus 8. So that would be 4. So that X is pineapple, Y is strawberries. So now we can write our therefore statement. Therefore, you need 4 pounds of pineapple and 8 pounds of strawberries. And then you can also do a double check with multiply 4 by 3 and you get 12. Multiply 8 by 1.5, you also get 12. And if you add those together, it's $24 for the entire platter. Okay, let's try the next one. Okay, Charlotte invested $800, part of it at 9% per year and the rest at 12% per year. After 1 year, the total interest earned was $79.50. How much did she invest at each rate? So before we begin this, we have to know what interest is. So when she's putting money into an account, let's say the 9% per year, at the end of the year, the bank would calculate what 9% of 800 is if she invested the entire 800, and then they'd add that to her account. Okay, so the question is, how much does she invest at each rate? So those are our let statements. Let X represent money in 9%. Let Y represent money in 12%. And now let's look for our statements. She invested $800. So if we took the money she invested at 9% and we took the money she invested at Y at 12% and we added them, it's going to be $800 in total. So that's our first equation. The next one is about the total interest. So when you take 9% of X and you take 12% of Y and you add those up, you're going to get $79.50 because that's how much money the bank is giving her. And now in these scenarios, when you take 9% of the money, you have to turn the 9% into a decimal. So 9% as a decimal is 0.09. If I want to take 9% of X, I'm going to do 0.09X. And for 12% of Y, I'm going to do 0.12Y. And in total, that's going to be $79.50. Now, you might be wondering, why can't I just do 9X plus 12Y? Because that's what we did with the mixture problems. So I'm going to go up there for a second, and I'm going to show you why it was okay to not put them in decimals. So let's look at this granola mixture, and then we'll revisit the interest one. I could have written this as 0.3X plus 0.15y equals 0.21 times 600. But because we know if you multiply an equation by any number, it will be the same equation, I could multiply this by 100, and then I'll get 30x plus 15y equals 21 times 600. And it's the same thing. So in this scenario, I'm kind of doing times 100 in my head and staying consistent. But with the interest one, I didn't want to do that unless you decide, you know what, I'm going to take the $79.50 and I'll multiply it by 100, but that doesn't seem very intuitive to me. Okay, so there's our system. And then you can solve this. And I'm not going to solve it. I'm just going to worry you with setting it up. But I do want you guys to solve it. So pause this video right here. Finish solving this. Write your therefore statement. And then come back with the final solution there. All right, so this is what we should have had. 550 at 9%. And 250 at 12%. So I chose to do substitution, but elimination would have been perfectly fine. All right, let's set up a few more and then that's it. So the next three examples are all distance, speed, time related. So before we do that, I want to refresh on the distance, speed, time triangle in case it is useful to you for remembering the distance, speed, and time formulas. So I always put speed on the bottom here, and then I think about when someone's driving and they're driving at, let's say, 100 kilometers per hour. The distance is on top and the time is on the bottom. So I put the distance up here and time here. And now you know what all the formulas are. The distance is speed times time. And if I want to do the speed formula, speed is distance over time, or time is distance over speed. So I have everything I need in this triangle. Now it's optional to use this. I personally don't like using it, but it's up to you. So let's try an example out. A canoeist took 2 hours to travel 12 kilometers down a river with the current, so the current is speeding them up and pushing them forward. On the return trip against the current, it took 3 hours. So now the current's in their way, so it's slowing them down. What is the speed of the canoeist and the speed of the current in still water? So those are our questions. So those are our let statements. Let X represent speed of canoeist, and then let Y represent speed of the current, and it's the current in still water. And now when you're going with the current versus against, when you're going with the current, the speed of the canoeist that he's actually going at and the speed of the current, they get added together for your total speed because you're speeding up. So with the current, you want to add your speeds, but against it, the current is pushing you back, so it's slowing you down, so you're subtracting. Now, to actually figure out the speed that you're going at, we go to our distance, speed, time triangle here, and speed is the distance divided by the time. So I'm just going to do a side calculation. The speed with the current was the distance, which is 12, divided by 2. So that's 6 kilometers per hour. Whereas when he's going against the current, it's still 12 kilometers, but this time it took 3 hours. So that's a speed of 4 kilometers per hour. So there's our linear system, and then you can solve using substitution or elimination, whatever you'd like. Now, the next one is very similar. So a passenger jet took 3 hours to fly 1,800 miles in the direction of the jet stream, so with it. And on the return trip, they were against the jet stream, and it took 4 hours, so it took longer. What was the jet's speed in still air and the jet stream speed? So I want you to try to do this one on your own. So pause the video, write your let statements, which are right here in the question, and then set up your with the jet stream equation and against. So please pause right here. All right, so your let statements. Let X represent jet speed. Let Y represent jet stream speed. So now I'm going to have a with and against equation. With, you're always adding, against, you're always subtracting. Okay, so for my with, the speed is going to be the distance, which is 800, divided by 3. So that's 600 miles per hour. And this speed will be larger than the other one. For the other one, we're going to take the same distance and we're going to divide it by 4 because it took 4 hours, and we get 450. So there we go. Hopefully you got these for your two systems, and then you could go ahead. I personally would solve this using elimination because it's already perfectly set up. The coefficients are already the exact same. So I can add my lines to eliminate the y's, or I can subtract my lines to eliminate the x's. Very quick. Now let's try one more distance, speed, time scenario. And this one is about driving or flying, canoeing, whatever, swimming at different speed intervals. So Jasmine drove the 540 kilometers from Toronto to Montreal in 6 hours. She drove part of the trip at 70 kilometers per hour and the rest at 100 kilometers per hour on the highway. How many hours did she travel at each speed? Okay, so here's the question. How many hours at each speed? So let X represent hours at 70 kilometers per hour, and let Y represent hours at 100 kilometers per hour. Now let's look at our statements. The first one is that Jasmine drove for 6 hours. X hours were at 70 kilometers per hour. Y were at 100 kilometers per hour. But if we add those 2 hours together, we should get 6 in total. The other statement will come from the total distance. The total distance is 540. And I'm just quickly going to write my distance, speed, time here. And we're talking about distance. So I'm looking here. distance is speed times time. So I know that they drove 70 kilometers per hour, so that's the speed, for X hours. That's the time. So if I write 70x, that will give me the total distance traveled at this speed for the first portion. So if they drove for 1 hour, 70. For 2, 70 times 2 hours, etc. For the second interval, they drove 100 kilometers per hour. So 100 times y would be the total distance. And if we add those two distances together, we should get 540. And then from there, you can go ahead and solve. So I want you to pause the video here, solve the system on your own, and then check with my answers after. All right, so here we are. Hopefully you got 2 hours at 70 kilometers per hour and 4 hours at 100 kilometers per hour. And if you made a mistake, check to see where you made that mistake so that you don't make it again.